So hey guys, welcome back to my channel. Hope you're doing extremely well, and this is your very own mass coder this side. In this video, we're going to discuss another problem of the GFG POTD, which is string subsequence, right? As the question states, it should be related to subsequences. So what does the question say? The question states that you have two inputs, string s1 and string s2. Now you have to tell me the number of subsequences of s1, subsequences of s1, that is this string, which are equals to s2, which are equals to this whole s2, right? So if I form the subsequences of s1, it will be ge gek, etc., right? I can choose any character, but the relative order should be same. That is, if I take the whole string, I can delete some characters, but g and k, like this g and k, if they are in the subsequence, they should occur at the relative position. G should occur before k only, right? This is a subsequence. So how can I form the subsequences which are equals to this, right? So I can see, if I index it 0, 1, 2, 3, 4, 5, I can see that if I pick this 0, this 2, and this 3, that is 0, 2, and 3, it will give me GKS only. So it is one of my subsequence. If I take this J with this K and with this S, that is 0, 2, 5, that is also subsequence. G with this K and this S, so that is 0, 4, 5, that is also a subsequence, right? Valid subsequence, right? Okay, so I think these are the only three subsequences valid for this one, because they are only giving GKS as their output, right? So the answer to this question will be 3. It might be more, but at the time I'm only able to figure out these three subsequences. The problem is, how will you solve this? How will you solve this, right? So we already know how to take the subsequences, right? We have already know, we have a knowledge of how to make out the subsequences, how to figure out all the subsequences, how to figure out all subsequences. The answer to this is take not take approach, right? Take not take approach, which uses recursion, right? What happens is, at each index, suppose my string is g e k s k s 0 1 2 3 4 5, and my recursion lies on this index. Now I have two options. I can take it in the subsequence, I cannot take in the subsequence, and move further. I will move to this index after this. In both the cases, whether I take it, whether I not take it, right? So at the end of the function, I will get all the subsequences. I will get all the subsequences. Now my task should be, if my subsequence equals to the string s2, in that case answer plus equals to 1. I will increment my answer, because I just found a subsequence which is equals to my s2, right? Which is equals to my s2. This is my first approach. But what is the time complexity here? So you can see that take not take approach takes exponential time, a very unoptimized time. So it will be O of 2 to the power m. Suppose s1 length is m, so it will be O of 2 to the power m. That is not a good approach, right? It will also take up space because of storing the subsequences. So space complexity is also not equals to O of n, it is equals to O of 2 to the power m only, because you are forming the subsequences, right? Now that is not an optimized approach, but this is a brute force approach. This is a valid approach, right? We have to find an approach which is working good. So I am saying that instead of finding the subsequences, we are just interested in the number. Our interest, let me mention it, our interest is the number. Our interest is the number. So why not play with that only? Why don't we play with that only? What I'm saying is, I have a string g e k s k s. Index is 0 1 2 3 4 5, correct? Now I am saying we have to calculate all the strings g k s, which are subsequences are equal to g k s, right? Index is 0 1 2. I say make a call for this index and this index, that is make a call for 5 comma 2. The string says that there can be two cases. Suppose this is string s1, this is string s2. There can be two cases, that s1i equals to s2j, right? And another case will be s1i is not equals to s2j. That is, these two characters are not equal. If they are equal, there can be two cases. I take this ith for the subsequence. I take this ith. So if I take this ith, I will move towards I minus 1, j minus 1, right? But if I don't take this, what will happen? I will move towards I minus 1, but j will remain there only. That is, I want to find the subsequences which are equal. So I can take this S, right? I can take this S and move further. That is, I have to find only GK if I take this S. But if I don't take this S, if I say, suppose say I don't want to take this S, instead I want to take this S. So I will move towards I minus 1 with J, right? What I am saying is I can take this S, I cannot take this S. If I don't take this S, I will be depending on this S only. Okay, so take, don't take are up clear too. But in the case of not equals, I only have don't take. I only have don't take. That is move towards I minus 1 with J, right? Now 5 comma 2 S I will move towards two cases, that is 4 comma 1 and 4 comma 2. 4 comma 1 K, okay, again two cases, 3 comma 0 and 3 comma 1. 3 comma 0, 3 comma 0, that is G and S. No options, I just have to move towards 2 comma 0, right? 2 comma 0 comes here. G, no, 2 will go to 1, 1 will go to 0, that means it will go towards 1 comma 0 and G1 comma 0 will go towards 0 comma 0. As soon as I see 0 comma 0, I have again two options. I can take this G, I cannot take this G. If I take this G, it will go towards minus 1 comma minus 1. If I don't take this G, it will go towards minus 1 comma 0. Now, my base case says if, first I will say if J is less than 0. That means if J is less than 0, that is all these three characters are found in the subsequence, in the current subsequence, that is return 1. But if that is not the case, and the subsequent base case will be, which we will mention below J, that if I is less than 0, that is this string has been explored whole, but J was not less than 0, that is this string has not been explored the wholly, right? That means this subsequence which I am currently dealing is not an answer, so return 0 in that case. What I am saying is if J less than 0, return 1. If I less than 0, return 0, right? That is, this will return 0, but this, because J has reached minus 1 also, so I will return 1 here. 1 plus 0, I will be reading 1 plus 0, 1, 1, 1, 1, 1. So 3 comma 0 is actually returning 1. 3 comma 0 is actually returning 1. Moving on to 3 comma 1. 3 comma 1. This 3 with this 1 not equal. I will go towards 2. So 2 comma 1. 2 comma 1 again has two approaches. K, K. I can take, I cannot take. If I take it, I will move towards 1 comma 0. If I don't take it, I will go towards 1 comma 1. Right? 1 comma 0, let us say. So E and 0 is J. No. It will move towards 0 comma 0. 0 comma 0. Which again has similar to this, exactly like this. Minus 1 comma 1, etc, etc. So I will be just using this value. As you can see, I am using this value. That is, sub problems are overlapping. Sub problems are overlapping. That means it is a clear indication of using DP. It is returning 0, or it is returning 1, so I will be returning 1. 1 here, 1 comma 1. I have to explore 1 comma 1. So 1 comma 1, 1, 1. You can see that there is no K left, so I will be returning 0 only. It will go further, like it will go further to 0 comma 1, and then it will go towards minus 1 comma 1, and it will then return 0, right? 1 plus 0, 1, right? 3 comma 1 is returning 1. 3 comma 0 is returning 1. 1. 1 plus 1 gives me 2. I will be returning 2 here. Exploring 4 comma 2 here. 4 comma 2 here. The case we didn't take S. This S. Right? What will happen? 4 is here, K, and 2 is S. It will go towards 3 comma 2. 3 comma 2 again has two cases. S, S. 3 comma 2 has again two cases. What is the case? 3 comma 2 says I take it. So 2 comma 2. 2 comma 1, sorry. I don't take it. 2 comma 2. 2 comma 2. Now I will say 2 comma 1. 2 comma 1 has already been explored. It is running 1. Simply return 1. 2 comma 2 has not been explored, so I will explore it. So 2 comma 2. Moving on 2 comma 2. K and S. You can see it will return 0 because S is not there. So what will happen is it will go towards 1 comma 2, 0 comma 2, minus 1 comma 2, and 0, 0, 0, 0, and it will return 1 because 1 plus 0 equal to 1. So I will be running 1 here. 2 plus 1 is actually now equals to 3. My answer will be 3. That also we explored, right? We explored the 3 1. We explored the 3 1, right? So what is the code we are using? We are using this recurrence test case, right? Let me write down the code for you. So what are we doing is, suppose I make a helper function which takes my string s1, s2, and the current index I'm storing. So I comma j. I is for s1 and j is for s2. If my j is less than 0, return 1. If my I is less than 0, return 0, right? We already explained it, right? Moving on. If S1I equals to S2J, the last characters of both the strings are same. In that case, return. What do I return? Helper for I minus 1, j minus 1. This is a take case. Plus helper of I minus 1 comma j. That is not take case. But in the else case, what will I do? I will simply return helper of I minus 1 j, because I don't have an option to take the current character, right? And then return has already been called, but I will, because I saw that overlapping subproblems were there, I just mentioned it here also, subproblems are overlapping, I will be using a DP array, right, which will be of dimensions n plus 1 into m plus 1, right? N is the length of S1, m is the length of S2, and I or j are same. So I am making a 2D array. Why? Because I and j are, like, my answer depends on I and a j. That is why I made a 2D array. If it was depending on only I would have made a 1D array. I will mention here, if dp of I j is not equals to minus 1, what will you return? Return dp of I j. And similarly, while returning this will come dp of I j equals to this, and similarly below dp of I j equals to this, right? And then your thing is sorted, and now you are fit to write the code. So let us move to the coding section. Alright guys, so here is the coding section, but before beginning with the code, I would like to request you to please subscribe to the channel if you are new here, and if you are liking this video, if you are able to understand the algorithm, please like the video, because it really helps me, it motivates me a lot, right? Moving on, I will say int n equals to s1 dot length, s1 dot length, right? And similarly m equals to s2 dot length. Now, are you able to see that if my m is greater than n, there is no way I can find an answer to the answer problem. I will always return with 0 subsequences. Why? Because subsequence maximum length can be n, and s2 is of length m. If m is greater than n, I cannot find a subsequence, right? Moving on, I will make a vector of vector of vector int dp of size n plus 1, vector of int m plus 1 minus 1, fill them all with minus 1, and now return the solve for, I will make a solve function s1 s2, current I am exploring n minus 1, that is the last index of s1, last index of s2, and I will send the dp with it, right? Now I will write the solve function. So int solve equals to string s1, and let me make a mode value also. It has been mentioned in the question that I want a mode value, so int mode equals to 1e9 plus 7, right? String s and s1, I am sending the string by s1 reference, because I don't want it to copy again and again. Similarly s2, and now int I, the current index to be explored, and vector of vector int and dp. Now if j less than 0, the base case is j less than 0, let me if j less than 0, return 1, but if I is less than 0, return 0. If dp of I with j is not equals to minus 1, in that case return dp of I j. Now moving on, first case, if s1i equals to s2j, characters are same. Two cases we remember, right? Take, not take. In that case, return dp of ij equals to, first case is solve for s1 s2, take, so I minus 1 j minus 1 dp, and take the mode value of it, percentile mode, right? Plus solve for not take approach, the not take approach, s1 s2 I minus 1 j dp, and here percentile mode, right? Now after adding them up, again percentile mode to avoid overflow, right? This will be my first case. Else, if they are not equal, I will just copy it, return dp of ij equals to solve for s1 s2 I minus 1, because I cannot take it, dp percentile mode, right? Percentile mode is just to avoid the overflow, right? It should work fine. Let us try to compile and run it. Hope it will work. Should not give any error, I guess. It is running fine. Let us try it for submit it as well. Submit as well. In the meantime, do consider subscribing. And it has been test cases have been passed 167-day streak. So thank you for watching, and we'll meet again tomorrow with a new video. Till then, stay tuned, keep coding, and also support the linked list series which is getting uploaded on a daily basis. Thank you. Have a nice day.